Welcome to the AI for Career Success video overview by Curt Robbins, where we help you get smarter than your competition. So what we're digging into today is a really fascinating case study. Our source for this analysis is a collection of excerpts from public discussions on LinkedIn, dated December 24th, 2025. And it really gets to the heart of what happens when a highly advanced autonomous system meets a completely unexpected real-world challenge. And it all really boils down to this one question. What can a citywide blackout possibly teach us about the single greatest challenge facing artificial intelligence today?
So let's set the scene. It all starts when a major city goes dark, and in doing so, it inadvertently creates this massive real-world stress test for its autonomous infrastructure.
The catalyst for this was a fire at a utility substation in San Francisco. And this wasn't some minor event. It knocked out power for well over 120,000 customers, plunging a huge portion of the city into darkness. And that's when the dominoes really started to fall. Power goes out, so of course all the traffic signals go dark, and chaos starts to build. But here's where it gets really interesting, the contrast in behavior. You see, the human drivers, they started to adapt. They improvised, using hand signals and making eye contact to navigate the intersections. The Waymo robotaxi fleet, on the other hand, did the exact opposite. They froze.
And that brings us right to the core of the issue, what we're calling the fail-safe gridlock. This is a perfect example of what happens when a system's core logic runs into a rare edge case, but not just once, at a massive, citywide scale.
Now, this is an absolutely critical point to understand. The problem wasn't a bug. It wasn't a glitch in the code. It was the system's intended logic, functioning exactly as it was designed to. The failure happened because thousands of vehicles executed that same logic all at once.
So let's take a second to define fail-safe logic, because it's key. This is a fundamental principle in engineering. The idea is that when a system faces uncertainty, like losing the signal from a traffic light, it's designed to default to its safest possible state. For a vehicle, that safe state is, of course, to stop and wait.
And this is where you can see the huge disconnect between the logic and the reality. The system was designed perfectly well to handle a single dark traffic light by treating it as a four-way stop. But the citywide reality was thousands of dark signals happening at the same time. This sheer volume completely overwhelmed the system's confirmation checks, leading to paralysis. The logic that works for one instance completely failed when scaled to thousands. Well, as you can probably imagine, an incident like this sparked a pretty intense public and expert debate, with a whole spectrum of different opinions.
On one side of that spectrum, you have figures like State Senator Dave Cortese. His perspective really emphasizes accountability. He argues that public safety and robust oversight can't be afterthoughts. They have to be non-negotiable prerequisites before you deploy technology like this.
Then you have the contrasting view from commentators like George P. They frame this not as a failure, but as a necessary part of the innovation cycle. From this perspective, these kinds of unforeseen events are actually invaluable teaching moments that build resiliency and, ultimately, lead to a better technology. And then there's a more nuanced analytical take. A commentator named Yoliana I pointed out that this wasn't really about bad AI or broken code. It was about a lack of context. The core lesson, she argues, is that pure intelligence has its limits. It hits a ceiling. The next frontier for AI has to be true adaptability in chaotic, unstructured environments. So with all that debate happening, how did the company at the center of it all respond? Let's look at Waymo's tactical response to what was, fundamentally, a systemic challenge. Waymo acted quickly. They publicly acknowledged the issue and then announced a 4-part action plan. This included a fleet-wide software upgrade to improve navigation at dark signals and a new commitment to coordinate more closely with city first responders. And the explicit goal of these updates was to allow the vehicles to, and this is their own phrasing, navigate these intersections more decisively. Now, that suggests a subtle shift in philosophy, doesn't it? From a purely passive, fail-safe response to one that's more assertive and adaptive, all while staying within safety parameters. So, let's zoom out from this specific incident and focus on the strategic takeaways, especially for any professional working with or leading technology initiatives. I think this really brings us to the key takeaway. True resilience in autonomous systems isn't about programming for perfect conditions. It's about building systems that actually anticipate and can gracefully handle the failure of the very infrastructure they depend on. This incident really forces a fundamental strategic question for both cities and tech companies. Do you focus on upgrading the world, making infrastructure more robust before deploying these systems? Or do you focus on upgrading the AI, designing systems that are inherently capable of navigating a world that is, and always will be, imperfect and prone to failure?
And that leaves us with a final, thought-provoking question. As we move forward, is the ultimate goal of AI to create perfectly controlled environments? Or is the real challenge, and perhaps the real promise, in developing an intelligence that can truly master chaos?
Thank you for joining us for this analysis.
This is where we teach you AI and help you get smarter than your competition.
To stay ahead, we invite you to subscribe to the AI for Career Success YouTube channel. Please also like this video to support our work, comment with your own thoughts, and share to help us reach a wider audience.
We look forward to seeing you next time.